Some calculations now with circuits, right? So remember, in a circuit you have to have a full circle around. Okay, so let's draw it like this. Okay, first example. Okay, now right, that's it up. Okay, so this is your power supply. So your battery or your power supply that you would have used in school, right, from the mains. So it's 6 volts. Now we've got 6 volts, so voltage, all voltage, it's another name for energy. So what you have is, you've charges that go from the plus to the minus. Now ignore what the charges are, this is a model, okay? So you have charges that go from the plus to the minus, okay, and that's called the current, right? The voltage is the energy, okay, that is given to these charges to get them to go around. So if you're 6 volts, you have more energy, so the charges will flow, more charges will flow every second, so more current will flow. So we have voltage, which is the energy. So I'm going to write energy there. We have the current, and the symbol for that is I from junior cert, okay, and that's the flow of charge, how much charge flows every second, okay, and then the charges are going around, and as we saw in the clip, in your clips yesterday, okay, it depends on what they're going through, okay, it could be harder or easier for me heading through, and we call that the resistance, okay, which kind of makes sense, how they resist the current, okay, and that symbol is R for resistance. Now what are they measured in? Voltage, I'll put the square brackets, are measured in volts, current are measured in amps, and resistance is measured in ohms, and that's a special symbol for that, okay, omega for ohms. And we have Ohm's Law, okay, Ohm's Law, which says, okay, that the voltage depends on the current, okay, and effectively this is Ohm's Law. There's several ways of writing it, okay, I'm going to write it like that, okay, it can also be written like that, okay, in effect we'll use that as our basic one, okay. So just a few quick questions, and this is what I want you to be able to do, okay. Right, so in this case, calculate the total current flowing in the circuit, okay, that's part 1, and part 2, okay, how much room we have, okay, calculate the voltage across 2 volt resistor, sorry, the 2 ohm resistor. Okay, so part 1, okay, so let's have a look. The total current flowing, we have the total voltage, I'm going to put a T on that. Now the total resistance, okay, so we're not going to go into resistors in parallel, but resistors in series like this, to get the total resistance, all we do is just add the two of them together, okay, just add the two of them together. So we get a total resistance here of 2 plus 1, which is 3 ohms. And if we have the total voltage and the total resistance, we're going to be able to get the total current. So now you may have used this triangle in this brush. If you want, you can go back to it, but I'm not going to use the triangle. We're going to use bit of algebra. Okay, so the voltage is 6 equals I times 3. Okay, so rearrange it. 6 equals 3I. Divide both sides by 3. I equals 2 amps. And there we go. Okay, that's that one done. Right, now the second one, the voltage across the 2 ohm resistor, right? We're going to do that by ratios. So I want you to think about energy, okay, and these are the questions I'm going to get you to practice now. I want you to think about energy, right? You have 6 volts of energy available to you. You must get it through the charges through a 2 ohm and a 1 ohm resistor. Which one is it harder? Well, it's harder to get through the 2 ohm. It's twice as hard, okay? So the ratio is 2 to 1, okay? So you need twice as much to get through this than this. So, okay, we're going to do it by ratios. So the ratio is 2 to 1, okay? So effectively what we're saying is 2/3 of it are needed for the first one and 1/3 for the second one. We have 6 volts altogether, so through the 2 ohm we need 2/3 of the 6, so that's 4 volts, and through the 1 ohm, which we're not asked for, we need 1/3 of the 6, which is 2 volts. So our answer is 4 volts. Okay, our answer is 4 volts, and that's always how you do it. Another way of looking at that, if you're good at ratios, is you say 2 is to 1. How does 6 divide in the ratio 2 is to 1? It divides in the ratio 4 is to 2, 4 ohms, 2 ohms. That's what you do. Okay, so that's what we're looking for the time being. Okay, right, so one more. Okay, so second way we can put resistors, instead of one after the other, is we can put them in parallel. So we join the starts of both of them together. Now you'd imagine in this case, and this is a bit odd, you'd imagine in this case that the total resistance would be more, okay? But it's not, because if you think about it, the charges are, and your cartoon guide to physics will help in this, the charges are trying to get through here. You're actually providing more space for them to get through by putting the other resistor in parallel. Now there is a formula, and this is the formula I want you to practice, okay? And you'll be given this formula. Now it's a little bit more interesting formula. It's 1 over the total resistance is 1 over R1 plus 1 over R2. For them in series, one after the other, okay, we kind of didn't write a formula for it, but remember you just add them together. So that's the formula for it. So here we have 1 over the total resistance is 1 over 3 plus 1 over 6. Now you can use your calculator, or more ideally use the common denominator to get your total resistance. So common denominator is 6, so you get 3 over 6, and don't forget at the end, okay, I put it over here, at the end you have to turn this upside down, so you're inverting that side, so you invert this side, and you get a total resistance of 2 ohms, which rather interestingly is less than the resistance of either of these. Okay, it's less than the resistance of either of these, and it always will be. Okay, so that's how you get to a resistance of 2 resistors in parallel. I'm going to get you to practice one of those now as well. Okay, so you have 2 types of questions there. I'm going to give you an assignment in 10 minutes on those. Right, if you're not certain, you just rewind and have a look at them again. That's the glory of the recording rather than the live setup. Okay, we'll talk to you on Tuesday, okay, when we're starting a new section. The new section will be on sound. Okay, bye bye.